Hello everyone. Now we are going to discuss about zinc air battery. I am Dr. Sankaranarayanan, Assistant Professor, Department of Chemistry, SNS College of Engineering. Zinc air batteries, it's a metal air batteries. Cells using zinc and air technology are energized only when atmospheric oxygen is absorbed into the electrolyte through a gas permeable liquid tight membrane. With the removal of a sealing tab, oxygen from the air is introduced into the cell. A zinc air battery usually reaches full operating voltage within 5 seconds of being sealed. Zinc air cell basically a primary battery, however, rechargeable designs for high power applications are possible by physically replacing the zinc electrode. They use oxygen content of the air as active mass, the positive electrode, cathode, and the porous body of a carbon with air access. This is the structure, that chemical diagram you can see that potassium hydroxide as electrolyte and zinc as a negative anode and negative, and oxygen that pass through it, that will be carbon is positive cathode. Okay, so what will happen? Zinc plus oxygen, that will form zinc oxides. An aqueous solution of potassium hydroxide serves as the electrolyte. The cell voltage for the chemistry is theoretically capable of 1.65 volts. However, almost all designs are optimized for less than 1.4 or 1.3 volts in order to achieve longer life. In this case, zinc anode, cathode is oxygen at atmospheric pressure, which means 1 atmospheric pressure. Electrolyte potassium hydroxide. Zinc air battery is a modern metal air battery. It is oxygen from the atmosphere and it does not contribute to the weight of the battery. So these batteries offer high energy density. So this is the cell representation. You can see that cathode and cathodic ion and separator and zinc anode and insulator glasses, all the things are there. So we can look at here. Anode zinc, cathode oxygen, electrolyte potassium hydroxide, cell reaction at anode, zinc plus 2OH gives ZnO plus H2O plus 2 electrons. At cathode, that half O2 and plus H2O plus 2 electron gives 2OH. That overall reaction, that zinc plus half O2 gives ZnO. This is the overall reaction, how the energy is produced with these cell reactions. High energy density but low power. In expensive material, the zinc air system, when sealed, has excellent shelf life with the self-discharge rate of only 2% per year. In the relations to their physical size, zinc air batteries store more energy per unit of weight in terms of 220 watts per kg than almost any other primary type. Primary cells available in the range of button and coin cell size, rechargeable high power cells available in the fraction of applications. So these are the question: which of the following advantages of alkaline but high energy density, good discharge character is override, and cheap raw material are used? So especially this will be cheap material used. So secondary cells are what are secondary cells? For example, lead acid cell, alkaline cells, or both. Especially the secondary cells are lead acid cells, that can be rechargeable. Lead acid battery, that will be as a rechargeable battery, that is secondary battery, that we can recharge and discharge.